All right. Hi and welcome everyone to our webinar devoted to our AI development agent. So as most of you know, AI is everywhere today. The trend is growing and it keeps growing. And it's not only affecting our everyday life and chats and productivity, it's affecting the software development as well. As Gartner predicted last year, that in enterprises, only about 15% of engineers are using AI code assistants. I think this prediction is way overdue because it seems to me that everyone is doing it now in some shape or form. And yeah, it's definitely gonna get there faster. So my name is Nick Frolov. I spent all my life working in software companies, writing software and managing the development of software in different roles. And these days, I'm heading Refact AI. Refact AI is an open sourced AI software development agent. You can check us on GitHub. Most of the stuff which I'm going to talk about is fully open source. We have some enterprise features which are closed source, but everything I'm talking about, the proof is in the pudding. You can go there and check it out and maybe even contribute yourself. The company has been founded by a former OpenAI researcher. We've been lucky to get featured by companies like Gartner, partner with AWS, featured in DeepSeek, and InfoQ, TechCrunch, and other outlets. This is very new news. Just a couple days ago, we published our blog post that we reached #1 score on SWE Lite. If you want to check the details, go on our website and see the article. So we are very proud of this achievement. We currently submitted a merge request to be fully featured on software development benchmark. And yeah, the kind of the key feature of our software comparing to all the other companies which you familiar with as AI coding assistants, our main difference is it works on premise and it also works as software as a service. And we've been lucky to be trusted by a number of large enterprises who work with us today. Again, this is not a new thing. There are many companies today which are doing something similar. So the way we position ourselves and the way we see ourselves is we're not there to compete to be your favorite IDE. We're here to focus on autonomous work and try to cover as much as part of the development to be done efficiently and automatically. We have a complex number of different parts in our solution. And it consists of the server side, which can have a model hosting or use external models. We have their enterprise features like team management, knowledge management, fine-tuning on your own data and statistics. And we as well have the actual agent or engine, which have different interfaces to work with. It has a custom line interface, it has a graphical user interface, and it's embedded in VS Code and JetBrains. Yeah, as I mentioned, we kind of have a unique way of deployment, which means that we can either work fully on-prem if you have the enough GPUs for that. We can work hybrid, where all your core data is within your company and the models are provided externally. Maybe in your company have a trusted cloud provider like AWS or Azure or GCP, and then we can plug in these models and use them. Or you can simply use our SaaS and try the software itself right away. So, but enough about us. So let's say you want to build your own development agent. And I think this is a good time also to maybe explain kind of the ideal target audience for my webinar. So I would assume that you are not an expert in AI, because I'm going to explain some basics. And also, I would assume that you're quite familiar with software development. So many of the terms which I will be using will be very heavy in the engineering side. All right, so yeah, it's incredibly easy to make your own AI code assistant today. All you need to use is have access to a model. Let's say it's a model from OpenAI, and send there a message through the API, and you will get the code generated. So simple as that. That's your AI code assistant. The agent part, or the agency itself, comes from the definition which I find really nice from Donald Davidson, is ability to make choices or ability to act. And several years back, when OpenAI introduced function calling, they provided this ability for AI models, for LLM models, to do those things. So essentially, function calling adds capacity to make choices and adds ability to act. So we can provide the different functions and their definitions and parameters, and we give model ability to call those functions, which actually do stuff. So that's really the basics of what the agents are. It's the ability for AI models to make actions themselves. So what do developers do, right? As quoting the famous meme, eat, sleep, code, repeat. With our digital twin, we don't really need to sleep and eat much, but we wanted to code. So more specifically, we wanted to be able to read our files, read our projects. We wanted to be able to change and make changes to the project. And we actually wanted to run code. And this one is quite an important one, and the one I want to talk about in the first place. So many of you have seen this type of headlines where companies roll out some AI features which try to summarize some data, whether it's emails, whether it's news, whether it's something, and only to find that there are a lot of errors and hallucinations where LLMs say stuff which doesn't exist. That's kind of a nature of LLMs. They generate statistical probabilities, and some of them might be nonsense. So this is where the very important part comes in, because writing code is actually easier than it is to summarize the news, because code can be tested, and whatever has been hallucinated can be verified. We will see result of that, and we'll be able to act accordingly. So again, to run code in kind of it's a generic term, and it can be many different things. It can be your test, it can be attempt to compile your project and look at the errors and warnings, maybe use some linter, maybe use some actually run your program and look at the execution logs. It can be run your server and connect with the browser. So it might be different things depend on what your project really is. But what's important is it's something which allows you to get the ground truth whether or not your project is working, something which allows to give feedback back to the AI and LLM. And from that, really start correcting itself. So kind of to visualize why it's important and why it's important premise. So those of you who are not familiar with polyglot benchmarks, this is the benchmark which is created by author behind the coding agent called Aider. And I'm actually a big fan of Aider and really like the founder, but we have kind of principally different ways how we look at running these benchmarks. So what Aider tries to do is it tries to actually give the model the files and a task and ask it to generate the code. Then it look at the results, run the tests, and check whether or not the model did what it's supposed to do. So essentially, we're testing just the model here. Our way of running it is different. So we allow our model to actually execute the test itself, see the results of the test, and then correct itself based on the results. And as you can see, this approach drastically reduce the errors and improve the reliability. So it's still not on 100%, right? The models are still not perfect, but it's an incredible difference on the accuracy of what the models able to achieve. And again, the results are slightly different. Some models able to use function calls maybe more efficiently than the others. There are different reasons why. But one thing for sure, any model you take, when you allow them to course correct themselves by running the tests, they perform much better and they're able to get the given task to the finishing line. So let's take a step back now and let's talk about reading files. So what do we mean when we talk about reading files? We want to know the structure of our directories and actual files. We want to be able to read the content, want to be able to search for some parts of the relevant content in these files. And yeah, you're kind of familiar with this Miller's law, 7 plus minus 2, which is the average person short-term memory limit. And my wife probably will tell you that I just have one, but yeah, most of people have that number, and this is fairly accurate. So the thing where I'm getting to is the models also have short-term memory number. So this is a screenshot from Reddit where a user complains that his code base grew to 30 Python files, and then the agent was not being able to work with the size of this project. So let's take a step back and understand how the models kind of work a little bit. So the first thing we need to understand is the notion of tokens, right? Here you see that what we do, we basically take chunks of words and we make numbers out of it. And essentially, tokens are the individual numbers given to the collection of those chunks of words. The rough estimate is, yeah, there is about 100 tokens per 75 words. And you can go yourself and check it on the OpenAI website, how this stuff works. So again, over time, first models being extremely limited on the context window, on the amount of tokens which they're able to keep up in the short-term memory. Modern models much more capable, right? So the models we're using today, on average, consume about 100 to 200K, able to work with about 100 to 200K tokens. And there are some outliers which are able to use like 1 million and 2 million tokens. So over time, more and more architectures become better to work with a bigger short-term memory. Now, why tokens are important is because our code base, the amount of symbols and characters in the code base become tokens. So again, this is kind of average numbers, but you should look at it that on average, per line of code or per typical, let's say, microservice code base, you will have around 10 to 15K of lines of code, which is already an upper limit for some of the models or not even fitting that. And don't forget that adding everything, adding all your code base in the context is also not the best solution, because it's only will slower the inference, slower the ability of model to produce results, and it doesn't guarantee a necessarily better result. It's actually, in most of the cases, produce a worse result. And yeah, and when we're talking about the real enterprise code bases, they have over 1 million lines of code, which doesn't fit in any of the most advanced models today. So the solution is very simple, is to divide and conquer. So for those who are familiar with the term RAG, or Retrieval Augmented Generation, it's basically a way, if we have a limited context, then we only give some relevant part on demand. And we actually provide LLM with tools to search for this relevant code, right? And when we're talking about which part of the code is actually relevant, we need to understand that not all lines are equal. So the developers among you familiar with abstract syntax tree, or AST, which defines a graph representation of the important parts within your code base, right? We're talking about the definition of your classes, methods, functions. Again, depending on your programming languages, there may be different terms. It also has references or imports, variables, calls. All of the stuff are connected, right? The definitions are connected to each other. And then what we want to provide to the model is ability to search for those definitions and references. And the important note here that, again, there are some huge files, let's say some huge JSON or HTML or XML. It's really hard to present it as a nice AST structure. So there's some differences when we work with those type of just structured formats. CSS is also kind of a weird one to work with AST. Anyway, the next important part is, so we want to do the search within our code, but we don't always spell exact name of our class or function to the model. So the way it's solved by using the technique called embeddings. So there is a semantical meaning representation of, let's say, majority of the words. And those models called embedding models. And those embedding models actually don't have 2 dimensions like I have here in the picture, but typically they have several hundred dimensions where those words are associated along the different semantical meaning. And with that, we're able to search for more specific meaning or more specific functions or classes or parts of our code without naming them as the same way as they named in the definitions. So in Refactor, we combine all of it. So everything I just mentioned, we do all those parts. We read the files, we make a graph of project assembly tree structure, and we give the tools to the model to search for that. We also take parts of the code and we embed it in the chunks, allowing to do the search of the relevant code parts. And on top of it, we also create part of the knowledge, which is not necessarily code-based, but maybe something from your text files or something which you provided individually, which allows then to find more relevance and help the model to have a context to do that. So here is a long slide with all the representation of the tools. There will be a video recording after that if you want to check it, or you can go to our GitHub repo and check them yourself, how they work. The main part, all of these tools are important to be able to read files. Now we solve some problem of how do we read files. So how do we actually change them? So it's actually surprisingly hard problem to nail. And within Refactor, we actually had a lot of iterations over how to do that. Within the model, Claude Sonnet is definitely the best performer of this task. It's able to make updates of the files better than any other model. And probably good note here is sometimes it's actually important to have give a model a way to do the revert. So what we do, we maintain the shadow Git repository, which does commit after every iteration and allows to do the revert back. And the list of tools is provided here. Essentially, it comes to very simple kind of definitions, but they come with a lot of iterations and a lot of kind of different attempts to do that, along with changing the prompts to make it happen. Okay, so we're talking about files, reading files, changing files. What else is missing? So again, the more context you have, the better. In Refactor, we started with a kind of handful of command line tools, allowing the model to actually run shell commands with approval of the user or with some permissions to do it without approval, to run, let's say, a debugger, to be able to connect to a browser, or to use some other CLI tools connected to, let's say, your issue tracker, if you're using GitHub or GitLab for that, or connect to a database and get data from there. The next important part of adding more context is using the model context protocol. So it became a huge thing. When I was talking about it the first time several months ago, no one kind of knew that really. And today I think we're hearing about it from all the different places. It's a huge, huge success in terms of what the open standards can achieve. The idea behind of MCP is very simple. Instead of everyone implementing their own integrations to different tools, there is a standard protocol which allows to make these integrations and everyone to reuse them. One of the example here is how the MCP server for GitHub integration might look like, right? Or looks like actually. So there are tools to list data from your GitHub data, like repositories, branches, pull requests, issues, and there are tools to modify them, right? To create issues or pull requests and so on. And we added support to MCP about a month ago, or maybe a little bit more. And we had a lot of great feedback on that. And I think, this is definitely the tool which, the integration point which allows everyone to be more successful. One kind of a simple illustration here is that by adding this agent which works with Codebase, right? As I mentioned before, so we have our agent, we have our LLM integration, we have a user, we have knowledge base, we have Codebase search, we have Codebase editor tools, but as well, we have our command line integration tools. In addition, now we have ability to go and check, for example, an issue in GitHub. So let's say we pull an issue from GitHub with our MCP server, and we find for some relevant code base. But we also allow model to, for example, go to, let's say we're using Sentry to gather our error logs, to go and find relevant error logs, because they will help us to identify the problem even better. So with this additional context, the agent will be able to perform its job better, and will be able to find the relevant problem more realistically. There are a bunch of services today which provide information about MCP. So here I collected at least several of them. But yeah, it's really a revolution out there. The example is usually quite simple. There will be all those MCP servers provided as a package, which allows them to be installed with whatever package manager you use, whether it's NPX, whether it's PyPI, whether it's UV, Docker, you name it. Main point, it's able to open a server and then locally, or now it also supports external servers, and be able to use the data. Again, ability to plug in data doesn't mean we should plug in all and every data. So the context limits, the short-term memory is still there, right? So we don't want to add millions of database records just because we can. If we use an external tools, external APIs, we still have the limits of how often we can connect to those APIs. LLMs, I already mentioned before, they have different capabilities in terms of how efficiently they use tools. And what I've seen, they're not today able to intelligently understand all of these different things. So be ready to provide relevant knowledge base or like wanted trajectories on which tools you want to be called in what order. Yeah. And yeah, majority of integration today are not official. So ideally check the code, but also some are buggy and some are partial. And on top of it, there might be some security issues. And again, it's kind of obvious there is some limit. I think the limit is about what, like 120 tools per model. I think OpenAI allows to have 120 tools, but yeah, just because you can plug in all the tools, it's not the best idea. It's, first of all, it confuses the models in terms of what it do. The other, it increases your cost, right? Because you get the bigger input tokens on the more tools you make available. And then, yeah, the security issue is, this is just an example that some people out there might actually put the incorrect data into the descriptions of tools, which might have some, essentially harmful way to get some data from you. Like here, for example, it might go and copy your key, right? So again, be careful in terms of what MCP tools you plug it in. Another interesting part, which I really like about MCP, and we've kind of been using it without MCP as well, but I really like the idea, is just because there are best models out there, it doesn't mean that you always need to use your best model every time. First of all, it's usually quite expensive. Second, there sometimes might be a different priorities. You might have cost or speed priorities. So in our case, we have, for example, a tool we call a deep analysis. And deep analysis tool is actually a tool which use the, let's say, more advanced AI model, and it allows your, let's say, working horse model to call the more advanced model when it's not able to solve something and needs some assistance. Another example of kind of the use cases where you want to use, let's say, your cheaper model is when you don't really care about the accuracy of result. Like in our case, where we generate some follow-up suggestions for the user, or we name the thread, we use the cheapest model available so that we don't spend where we should not spend. Yeah, so I kind of ran through a lot of stuff here, but as you can see, in reality, it comes down to these things. We read files, we change files, we run code, and we add additional context, right? Whether it's your database, whether it's your log files, whatever you have to do that. That's kind of how the AI agent work under the hood. Again, I invite everyone to go and check our repository if you want to kind of get your hands dirty and look at it yourself. But if you're willing to actually try and how to use it, go on our website. We have a free plan which is available to try the agent and check it yourself. And if you are willing to connect with other people who are working with agents or working with AI, we have a very active Discord community, which we also invite you to join. All right. Yeah, that's really all I had prepared from my side. And I was able to actually do it quite quickly, within just half an hour. So let me see if there are any questions which my colleagues will pull up from you. Please feel free to write in chats. I think we're live in LinkedIn and YouTube and X, and you can send your questions there, and I will be able to see them. All right. Okay. Yeah. Do we have any questions which out there? Okay, I see one. Yeah, they're going to be. Yeah. How do I make those questions? All right. Looks like I'm able to pull them right there. So how's the situation with Qwen 3? Yeah, so we already added support of Qwen 3. It should be in the dev build of self-service. It's also should be available in our dev build of the agent. And yeah, in general, it looks quite promising, to be honest. haven't done finalize our benchmark results. With Qwen 3, we had the similar issue which we had with Gemini, where we had to tweak a little bit the prompts in order for it to be able to finalize the testing. But yeah, with Qwen 3, we looking for the challenge there is also to provide the big enough model with tool support, which we haven't been able to see from external providers. And ourselves, again, anecdotally, so far it looks promising. It's not better than the commercials models out there, but yeah, it's quite good. Yeah, the questions related to are there going to be video recording? Yes, there's going to be a video recording. Are we planning to share the benchmarks of different models? Yeah, we actually, again, we hope that we'll be able to actually make our benchmark repo public at some point. We're still kind of finalizing the wiring for that. But yeah, so for us, it's also something which we have to kind of combine all the different activities, like whether we're doing research or whether we're doing development, and we try to balance those things. Okay. Are we going to learn how to build these agents or how to use them? Timely questions, given the fact that I just finished the presentation. So in general, what I was describing is, I was describing in general terms how this machinery works, right? Because if we will do the deep dive technical sessions, that will take us the whole day. I invite you to go and check our open GitHub repository. We wrote our agent on Rust, so that's kind of the way we do it. But again, different people, different repositories, different agents have different ways to do that. Yeah. I don't know if we have any other questions left. Yeah. Well, again, thanks everyone for joining me today. Again, the video will be available. All right. Okay, there's still one more question. How does a Refactor agent understand and adapt to different code bases? So again, there are two parts which are important. One part is, like I mentioned before, all these ways which allows give agent tools to read the repository and read your files or read your extra data. All this stuff is become a way to understand your repo. But in addition, what we do, we maintain a knowledge base. We have kind of two different ways of that. An enterprise version, we have a team knowledge base, which allows to basically the whole team to share the knowledge about how the repo is structured or how the product is working, and stores the trajectories in terms of how the files are organized, kind of the repo grokking term, which is often used. Yeah. And also we have kind of a knowledge base, a local knowledge base, which stores this data. Yeah, usually when I start my work, what I would do is, it's kind of my prompting tricks. I would ask an agent to find a relevant code to some particular functionality. So that will basically trigger it to add into the context all the relevant search in all the relevant code bases. And then what I will do once it done this part, then if I would start asking to start making some changes to this functionality. So then basically I make it with two-step, with making the first step as preparational step for it to identify everything relevant for me. Yeah. Okay, someone asked about our repo. If you go to refact.ai, you will see a link to GitHub. Okay, yeah. Again, there are different goals there. Refact started with training on models, on completion models, and way before the agents become the thing. Today, we really want to make a tool. I myself, like I said, was developing for 20 years, and I really want to make a tool which I always wanted to use as developer. I'm using it myself today, both to write our own agent, and I'm really happy to see that our, for example, quality assurance people also using our agent. So there was our QA tester, instead of just typing the bug, was able to make the quick fix himself just by using agent. So that's kind of changing your whole software development lifecycle. The existing tools, if you're talking about existing tools, I don't know, like Cursor, Windsurf, those are commercial tools, and our model is different than theirs. If you're talking about the other open source tools, I think I have some frustration in terms of what other open source tools can do, and we're kind of trying to go it our way on this. Is Refact building any in-house model development? Great question. So we started with building our own model. We put it on pause because the competition on this is too immense, and that requires too many resources. What we do is we see that collecting of trajectories on knowledge bases becomes incredibly important. So we probably will be. I don't think we're gonna kind of release our own models. More likely that we will support, make some fine tunes for specific tasks in the future, which are focused on, let's say, a particular technology or a particular use case. Yeah. All right. One more time, thanks everyone who joined. Thanks for the kind words in the comments. I appreciate your time. The video is going to be available right away. And if anything, just send me a message, and I'm happy to chat. Thanks. Have a good day.